Hello, I'm here with Simon Wardley. And Simon.
Thank you. It's a pleasure to be here with yourself and the cameraman who is still hiding off camera. I think we should turn this around so that everybody gets to see him at least once.
Yeah, okay. Thank you for your time. And
Pleasure.
we just saw your keynote and I would like to ask you something about it.
Shoot, go away. Other than, can I have my money back?
Okay. Good, maybe not. So my first question is, what are your thoughts about the idea of letting AI making strategic decisions?
Oh, gosh. Right. Well, so that's a really interesting one, because ultimately when you think about software engineering, what it is, it's a decision-making process. And when we think about architecture, the architectures that we have are not in the diagrams, they're just statements of beliefs of what we think things are. It's all in the code. The code is the architecture. So when you work with maybe a co-pilot or you're vibing or whatever it happens to be, the question you always have to ask yourself is, how much of this am I happy for the large language model, where it's a multimodal system, to make the decisions for me? So when I'm prototyping, I use vibe coding. I don't like to call it coding, it's more wrangling, because it's a non-deterministic language. I'm trying to wrangle it into creating something useful, and I can do so at incredible speeds. But what I'm surrendering is my decision-making and my architectural decisions to the machine, unless I go and look at the code. Now, as soon as I look at the code, I'm into the world of software engineering. This is the point at which I'm saying that human involvement in that decision-making process matters. So, am I comfortable about using these tools? Yeah, absolutely love it. I do all the time. One of my favorites, an environment called Lovable, lovable.dev. Am I aware that what I'm doing is, if I don't look at the code, is handing over my decision-making and architectural decisions to the system? Absolutely, and I'm doing that consciously. Most of the stuff, though, that I'm building will have some element of software engineering, so some human process in that as well. And I'll still use large language models and systems like Cursor to help me improve code, but I will still be assessing and looking at the code. You have to be careful. Mm-hmm. The reason why I say that is I was building a particular system. I was using very much vibe wrangling to build the system. So I wasn't looking at the code at all. I was getting the system to build it for me. And I decided it'd be really useful to have testing and test engines in there. So I got the system to build a test engine, and every time I added new functionality, I'd get it to write a test and include it. And I was loving this because I could run my tests and I could see all my tests passing, and it was great. And every now and then there'd be a problem. I'd copy the logs because I got it to have a little log window and put it into the prompt. So this is what happened. But something wasn't quite right. And after a bit of time, I couldn't resist it anymore. I went and looked at the code. And when I looked at the code, what I actually discovered was it wasn't testing the code. It built a simulation of a testing system. So it had worked out a frequency at which I probably would want to see different tests every time I updated the version number. And every time it wrote a test, it wasn't actually testing the code. It was writing what the message was likely to be if there was a failure. So the whole thing was simulating a testing environment when there was in fact none. So you have to be always mindful that when you are in that space and you've handed over those decisions to the machine, that what it does might not be what you're hoping or thinking it does.
This links a bit to my next question, which strategic mistakes do you see in AI adoption, and what is your recommendation for a better evolution with AI?
Oh, right. So first of all, when we're talking about co-pilots, conversational, I like to use the term conversational programming. It's what I called it back in 2018. So when we talk about CHOP and Vibe and co-pilots, we're talking about building systems where the machine is part of the conversation with you as well. And that's all based upon industrialization of parts of machine cognition with large language models, large multimodal models. That, of course, creates these new chains of practices and enables you to quickly build new things. Now, that gives you things like efficiency, speed, and new value. And if you are in competition with others, as more adapt, the pressure on you will mount to change and end up with a result that there is no choice over this stuff. So the first mistake is people thinking that they have a choice over the use of large language models in development. No, you don't. You will eventually be doing this stuff. So now the second mistake that people make is that we won't need software engineers. If you map out an environment, you can see that certain parts of it you might outsource, some bits you might do vibe wrangling or vibe coding or whatever you wish to call it, and other parts you're going to have more software engineering. Yes, they're going to use large language models and cursor and things like that to do that, but humans will inspect the systems. And we're likely to see an explosion of new things being created through vibe wrangling, as a result of which some of those things we will want to maintain and keep for the longer term. So you're going to end up seeing a lot more software engineering. So the second mistake that people make is this idea I can get rid of my software engineers. Honest truth is you're probably going to need more of them. You're just going to do vastly more stuff. So first mistake is I have a choice. You don't. Second mistake is get rid of my software engineers. The third mistake is we make decisions without looking at the context, which is why I said you map out the environment and we can work out what we need to use where. Because ultimately, one of the key decisions that an architect needs to make is which parts of the system are we going to care about that humans are involved in the decision-making process, and which parts do we not care about humans being involved, where it's perfectly fine to have the machine created it, even if it's a hallucination of something. That's okay, that suits our purposes. So for example, prototyping, fabulous. If you're building prototypes without using one of those sorts of environments, I mean, you're probably missing a trick. That does not mean everything will be built in those same environment. And yes, our comfort level with those different environments will change and evolve over time as the systems do.
Can AI replace the idea of Wardley mapping?
Oh gosh!
I mean, you are the right person to ask.
Yeah, no. I think so. Friends of mine and have trained up various large language models to generate Wardley maps. And the thing about Wardley maps is it's the conversation, not the actual artifact that's actually produced. And yes, I've seen various of these artifacts, and I find them useful in the fact they give me things to think about, which I may not have necessarily done. So I find that as positive. I would say that the output of the maps themselves at the moment, it's got a bit of a way to go, but will it eventually get there? And yes, and at which point then we can have the more interesting conversations about what we do with the environment, how we change the environment. Now, eventually, will a machine get there in playing those sorts of games as well? Sure, eventually it will do, and then we'll either move on to something else or discover that machines are making all the decisions for us, and maybe we'll be happy at that stage. A little bit of time to go yet.
You encourage critical thinking for several reasons. Why?
There's two sides to this. So we'll start with the large language, and then I'll go to the general education side. So if I think about, if you map out the evolution of technology, one of the things that you notice that's going on at the moment is our tool sets are changing. We're going from sort of a very our traditional software development environments to things like copilots. Our language is changing. We're going from declarative languages to much more prompt conversational languages to go with our conversational environments like copilots. Now these languages, they are computing languages, Turing complete, if they've got memory. But they are a very different type of language because it's conversational, somewhat non-deterministic, rather than what we're used to. The medium is also changing. So we're going away from code as text, including things like code as images. So you can do this with generative AI when you give it an image and use that as the seed to create something else. Now, why does that matter? Because if you think about any engineering department, in any engineering department, there's a conversation that occurs on the code on the screen, which is about syntax style and the rules to coding, and the same conversation also occurs on a whiteboard. But in a whiteboard, we use a much more visual environment, and we're normally talking about objects, relationship, and context. So we have very different conversations depending upon the medium that we're using. Now, why do I mention this? Well, tools, language, and medium are fundamental to how we reason about the world around us. And if those are controlled by any one party, they exert enormous amount of influence on your ability to reason. Or we'll take you take any group you don't like in history. Imagine they controlled the tool, the printing press, the medium paper, and the language, the written word. Then they control how you think about things. You come up with ideas like evolution. They might go, I can't have that word, can't write a paper on that, can't describe. Very powerful. So one of the dangers we have to be very mindful of is the tendency of large language models and large multimodal models, these systems which we group as AI, to create new theocracies. If we hand control to a small group, that's what we're doing. The counter is to take a much more open approach, which I think would encourage more of a new enlightenment. And we're seeing that with China and France, which is really positive, except for the lobbyists will tell us, danger, danger, that's how you get Skynet and blah, blah, blah. So you've got that fundamental debate in there between, theocracy and creating more of a new enlightenment. Open is one tool. The other is diversity of sources. The other is critical thinking. So critical thinking is also very important for us in terms of when using these systems to think about the answers they're giving, rather than being sucked into believing there are 2-kilometer structures underneath the pyramids and it was built by aliens. So now let's go to general education. I took a whole bunch of people working in the education field, professors of education, all this sort of stuff. We mapped out education from multiple different perspectives. And the reason you do that is if you map out Paris, suppose no one's ever mapped it out before, you send a group to map out Paris, you say what's important, they might tell you Pierre's Pizza Parlor because they've mapped it from a perspective of nice places to eat pizza. So what you do, send multiple groups to map from different perspectives. Then you can aggregate and find what really matters. In education, for social benefit, what really mattered was lifelong learning and critical thinking. Now, for the market benefit, financial benefit, what really mattered was digital transformation and use of AI in schools. So we have this, it's often the case that sometimes, quite rarely, do social benefits and financial benefits line up. Most of the time, there's quite diversity between them. And so we have this unfortunate situation that we have these growing AI systems which we, in order to deal with safely, we need to encourage critical thinking, but we have education systems which don't invest and encourage. As much as teachers want to, education is not normally run for the benefit of students, it's run for the benefit of governments and the creation of useful economic units. And unfortunately, in that world, things like digitization, using AI in schools matters, not critical thinking. So we have some challenging times ahead of us, of which critical thinking is a really important part.
Yeah, and then what are your recommendations to the young generation of software architects and regarding the rise of AI and decision making? I mean,
well, do a course on critical thinking. I know everybody thinks it's not important. It is. Make sure, encourage the use of critical thinking. Don't be afraid of change as well. I mean, you're gonna get people who will argue that large language models will get rid of all software engineers. I think that's wrong. But you shouldn't be afraid of using them as well. And there's certainly part of the problem with software engineering, whilst we use them in software engineering, we've got some general issues with software engineering to do with tools and tool sets. And this is part of something I'm writing on, rewilding software engineering, because we've got ourselves trapped into this sort of belief that we can have standardized tools for highly contextual problems. And it turns out there may be a better way of actually doing engineering. If you look in the physical engineering world, we do this all the time. We build the tools to solve the problem, then we solve the problem. In software, we seem to have, we've missed that lesson. So for a budding software engineer, do something on critical thinking, learn about the subject, good thing to do. Don't be afraid of large language models and use of them, including vibe coding, or as I like to say, vibe wrangling, because I think it's more wrangling than coding. Don't be afraid of using it. I would encourage it as well. And I would also encourage people to look into the concept of tools and tool sets and how we do things. So To make it really short, if you imagine a physical world, I like making soup, so I use a kitchen blender at home. Now, if I was building a deep shaft mine, I wouldn't use a kitchen blender to do it. Okay? I would use a tool which is much more contextual to the problem of deep shaft mining. I certainly wouldn't use, oh, I'm rubbish at using a kitchen blender, but look, this person's using robots with kitchen blenders. Okay, yeah, the robots will be better than me, fine, but still I would be better than them if we actually used a deep shaft mining tool. Well, in software, the tools and the language, the tools and the applications are all symbolic instructions, so they should be easy to adapt and mold, but we've got trapped in a world of standardized tools from tool vendors. And those tools are built to solve a problem, it's just not your problem. And so when the fact that we try and use the same tools to do electronic healthcare record system and an online gambling site makes no sense at all. That's like soup and deep mine shaft. I mean, so we have some real questions to ask ourselves about software engineering practice.
Simon, thank you very much for your insights and your time. Thanks.
It's been a delight. Thank you.